Good evening. Now, in the last class, I told you about that we have to go for the equations and regression lines. Okay. See, this regression lines, first of all, will take into account the two variables. In these two variables, that is x variable and y variable, we have to take into account the two variables, and in this, we have to make one variable as independent and the other one as dependent. Okay, like this we have to go for the other things. So thereby you will come across two lines, and these two lines, they will take into account the correlation aspect also. When you go for coefficient of correlation, the coefficient of correlation, it should lie between +1 and -1. Okay, so when you come across these things, okay, the lines, they will vary. Okay, suppose when they coincide, then automatically it is said to be that the correlation is either +1 or -1. In that case only. Suppose if the correlation coefficient, if it is 0, then the regression lines, they will be parallel to OX axis and OY axis. Okay, like that they will come. And basing upon the lines only, you will have the equations. So what are these equations, sir? It is nothing but the algebraical expressions of the regression lines, that is x on y, y on x. This is nothing but the algebraical expressions that we come across. Okay, and what are the equations that we come across is, what is a change in one variable, and when there is a change in one variable, what is the value of the other variable. Like that, the equations, they will take into account. That's why you will come across two equations, regression equation of x on y and y on x. Like this, two equations will come. And here, when we go for this regression equation is equal to yc is equal to a plus bx. Okay, yc. So what is this yc, sir? Computed y values. When you take into account one equation, that is first of all regression equation of y on x, here y is dependent and x is independent. When you go for this, the regression equation is yc is equal to a plus bx. Here a and b are nothing but the constant values, and people, they will call them as parameters. Okay, people, they will call them as parameters. Okay, when you take into account the parameter a, it will determine the level of fitted line, that is which line is best fitted. And when you go for the parameter b, it tells us about the slope of the line. So like that you will come across. Here the parameters a and b are constant, they won't change, and basing upon the parameters only, the estimated values or the computed values of any variable, whether it may be x or whether it may be y, they will be determined. And here I told you that the parameters of the equation, when they are constant, okay, for whatever it may be the change in the value of one variable, the value of other variable also will change. For example, if you take into account regression equation of x on y, okay, here y is independent and x is dependent. Whatever it may be the change that we come across in y variable, with that the x values will change. In the same way, when y values change according to the changes in x values. This is about the regression equations. And when we want to know the estimates, or when you want to know the computed values of one variable, okay, we have to take into account the help of method of least squares. With that only we can come to know about the values of parameters. Once if you come across the parameters, once if you know the value of parameters, automatically you can go and you can estimate, or you can find out the value of other variable. And when you go for least squares method, we have to take into account two normal equations. We have to take into account two normal equations, and by solving these two normal equations we will come to know about the value of parameter. And after substituting the value of the parameter in the equation, first one or second one, whatever it may be, you will come across the value of the parameter. With that only we can satisfy the regression equation. Okay, that is, if it is x on y, okay, if it is x on y, the equation is yc is equal to a plus by. If it is y on x, it is yc is equal to a plus bx. Okay, whatever it may be, whether you go for first equation or second equation, whatever it may be, okay, the values only they will change, but the parameters they won't change at all. You have to keep that in mind, because parameters are constant. They are constant. And when you go for this best fit line, okay, we have to take into account the help of method of least squares. Why? Because, okay, whatever it may be the deviations, whatever it may be the difference between the actual values as well as computed values, they will be minimum when you go for y or when you go for x. So for example, okay, when you go for y on x, okay, you will come across the computed values of y. So y minus computed values of y, when you take into account the total, okay, it should be minimum. It should be minimum than the y values. Mind it. Or in the case of x also, you will come across the same thing, x minus xc, and the sum of those things, the difference of those things, the sum of the differences of those things, they will be minimum. Okay, so what are the characteristics that we come across, okay, taking into account the least squares method? It gives the best fit to the data in the sense that it makes the sum of the squared deviations from the line sigma y minus yc square is smaller than they would be from any other straight line. This property accounts for the names least squares. Okay, they will be minimum. Second one is the deviations above the line equal to those below the line on the average. This means that the total of the positive and negative deviations is 0. That is, sigma y minus yc is equal to 0. The straight line goes through the overall mean of the data, that is bar x as well as bar y. When the data represent a sample from a larger population, the least squares line is large. The least squares line is the best estimate of the population regression line. That is, when we take into account the population, there we have to take into account the least squares. Okay, so I told you in the previous class that we will come across three ways of calculating the trend values or estimated values. The three ways are, when we take the raw data, that in that way we can able to find out the trend values. The second thing is taking deviations from arithmetic mean, and the third one is taking deviations from assumed mean. Whatever it may be, you will come across, you can calculate the trend values. Okay, you can take the trend values, or you can estimate the trend values, or you can compute the trend values of any variable. When you go for regression analysis, one thing you have to keep in mind is, okay, one variable is independent, and you have to find out the values of the dependent variable. If you take x, okay, you have to find out the x values. If you take y, you have to find out the y values. So like this, you will come across three ways, three methods or three procedures to calculate the trend values. First one is when the raw data, when it is given. When you come across the raw data, you have to apply the normal equations of least squares method. And what are the normal equations that we come across? The normal equations are two in number. First one is sigma y is equal to NA plus B into sigma x. That is the first equation. Second one is sigma xy, that is covariance. Mind it, sigma xy, whenever you come across, you have to call that thing as covariance, please. Sigma xy is equal to a into sigma x plus b into sigma x square. That is the second equation. So these are the two normal equations that we come across when we go for least squares method. So these two normal equations we will use when we are taking the raw data and when we want to get the computed values of the dependent variable. Okay, this is one thing. Whether you take into account anything, any equation, whether regression equation of x on y or regression equation of y on x, anything, any equation, this thing is compulsory. That is, in the place of x you will come across y, and in the place of y you will come across x. That's all. That is only the smallest change that you will come across when you take into account the raw data. Okay, fine. Let us go for the second one. Okay, let us go for, that is when deviations are taken from arithmetic mean. Okay, so there you will come across regression coefficients. Okay, for example, regression equation of x on y. So for that, x minus bar x. Okay, previously I told you that we have to take into account the arithmetic mean of both variables, that is bar x and bar y. So x minus bar x is equal to r means the correlation coefficient into standard deviation of x by standard deviation of y into y minus bar y. So you have to take into bar x and bar y are the arithmetic mean of x series, and bar y is nothing but the arithmetic mean of y series. Okay, r into standard deviation of x by standard deviation of y is known as regression coefficient of x on y, and this thing, okay, it will be denoted by bxy or b1. bxy or b1. For the second one, okay, for the second one, it will be different. Some people they will ask, sir, what is this regression coefficient? Is there any simple way for that? Yes. When you want to find out the simple way for bxy, that is b1, it is nothing but sigma xy by sigma y square. That is sum of covariance of x and y variables by sum of product of covariance of x and y by square of the y. Okay, sigma y square. That is sigma xy by sigma y square. That is the easiest way to calculate this regression coefficient of x on y. So just opposite to that, you will have this thing. That is regression equation of y on x. Y minus bar y is equal to r into standard deviation of y by standard deviation of x into x minus bar x. I just told you that we have to interchange. Okay, taking into account the dependent and independent variables, we have to interchange. That's all. There is a matter. But there won't be any other things apart from this. Okay, you have to interchange. So here, correlation coefficient into standard deviation of y by standard deviation of x, we can denote that as byx or b2. byx or b2. So what is the simple formula for that? Sigma xy by sigma x square. Sigma xy by, that is the numerator will be one and the same, only the denominator will change. When you go for x on y, you have to divide with y square, and when you go for the second one, you have to divide with sigma x square. That is the difference that you will come across. Okay, and whenever the arithmetic mean, when it is in denominator, fractions, then we have to take deviations from assumed mean, and we will see this in the next class. Thank you.